Why are governments now trying to predict wars the way economists predict recessions? Why are intelligence agencies talking about probability scores instead of secret briefings? And why might the next conflict be anticipated by an algorithm months before a single soldier moves? In 2026, the era of pure strategic surprise is shrinking. Conflict is increasingly treated not as a mystery solved by intuition, but as a statistical probability calculated by machines. Machine learning systems are designed to detect patterns humans miss. Before Russia's 2022 invasion of Ukraine, open-source analysts noticed unusual logistical signals, including the movement of blood supplies and field hospitals near the border. Traditional diplomatic interpretation initially dismissed these as signaling tactics. AI-driven models, however, flagged these as operational indicators consistent with imminent action. Today, platforms such as Views, the Violence and Impacts Early Warning System, generate monthly forecasts of conflict intensity. In late 2025, Views projected a significant rise in fatalities in Sudan based on socioeconomic stress, climate pressure, and historical conflict patterns. These systems do not guess. They calculate risk using historical correlation and real-time data. Modern predictive AI looks beyond visible troop deployments. It detects what analysts call dual-use anomalies. For example, if a state shifts grain reserves into hardened storage facilities, moves financial reserves into gold, and increases encrypted radio traffic simultaneously, machine learning models interpret this cluster as a spike in conflict probability. Individually, each signal may be harmless. Combined, they form a pattern. Conflict prediction is no longer about tanks crossing borders. It is about detecting subtle systemic stress signals. Machine learning is also being used to forecast civil unrest. Natural language processing tools scan millions of social media posts to identify surges in hate speech or ethnic polarization. In regions like the Sahel and Myanmar, researchers have observed spikes in inflammatory rhetoric preceding localized violence by weeks. The Early Warning Project, developed by the U.S. Holocaust Memorial Museum and academic partners, ranks countries annually based on statistical risk of mass atrocities. Variables include infant mortality, past coup attempts, regime type, and economic fragility. This is not speculation. It is probabilistic modeling applied to political instability. Predictive intelligence is no longer used only by militaries. Financial institutions integrate geopolitical risk models to assess sovereign default risk during conflict. Logistics firms monitor AI-driven threat dashboards to reroute shipping lanes before choke points become active combat zones, as seen in Red Sea disruptions. Humanitarian organizations use anticipatory action models to pre-position food and medical supplies before violence escalates. Stability has become a quantifiable variable in global markets. But this transformation introduces a dangerous paradox: the preemption trap. If an algorithm predicts high probability of war and a government mobilizes troops in response, that mobilization may confirm the adversary's fears, accelerating the very conflict the model predicted. In 2025, reports suggested an AI-based alert along the Ethiopia-Eritrea border misinterpreted agricultural logistics and routine drills as invasion preparation. The risk is not just false positives. It is feedback loops, where algorithmic prediction shapes political behavior. We are entering an era where the strategic advantage may belong not to the state with the largest army, but to the one with the most accurate predictive engine. Yet algorithms process correlations, not intentions. They detect patterns, but they cannot understand pride, miscalculation, or deception. In an anarchic system, prediction can enhance stability, but it can also compress decision time, amplify suspicion. The fog of war is thinning, but the friction of the algorithm is rising. The question is no longer whether we can predict conflict. The question is whether we can interpret prediction without triggering escalation. And now that you understand how AI models attempt to forecast war before it begins, the next step is to examine how algorithmic propaganda shapes perception once conflict actually unfolds.